Welcome. We are going to discuss about factorization of quadratic expressions and equations, which is a highly tested topic in all forms, from Form 2 to Form 4. In KCSE is where you find that examiners, after they give you maybe question on indices, the final approach is about quadratic expression and equations, or even maybe polygons. It can be anything, and it takes us back to quadratic expression. So we need to be equipped on this area. So what is a quadratic expression? To begin with, a quadratic expression is an expression of this format: ax squared plus bx plus c, where a, b, and c are all constants or integers or whole numbers. So maybe positive whole numbers, negative whole numbers, or even 0. At times you may find that b and c can also be 0, but a should not be equal to 0 for it to remain a quadratic expression. We have to get that x squared, because this square here is what qualifies it to be a quadratic expression. So when we talk about factorization, there are a few points we need to know. So I'm going to pick the next slide here, so I might write an example there. You may be told to factorize x squared plus 7x plus 12. A very simple expression, quadratic expression. Now you should know that in our case, a is 1, b is 7, and the c is 12. So here is where we have our a, my b, and my c. Something else you should know is that there are two, for us to factorize well, there are two factors or values we should come up with, which when you add them, you get the b part, and when you multiply them, you get a times c, or a and c. So which are those values? When you sum them, you get 7, and when you multiply them, you get 12, because 1 times a times c, 1 times 12 is 12. So which are those values? Because they are the ones that are going now to help us to factorize this one correctly. Now there is my simple approach here that I normally use. I normally get this product, which is 12, and find its multiples. So the multiples of 12 are going to help us to know which are these factors. What are multiples of 12? 1 and 12, 2 and 6, 3 and 4, 6 and 2. So we have started repeating ourselves, because you can see this one is right here, so we can stop at that point. Now once we get all these multiples, now we can start looking at each and see how can we combine them to give us a sum of 7. Can 12 and 1 give us a 7? No. Even if we subtract 12 from 1, we can not get 7. What about 6 and 2? If we subtract 6 and 2, you get 4. 2 minus 6, you get negative 4. So they are not the 1. So now we have disqualified that one and also that one. So we're looking at the third one, 3 and 4. When you add 3 and 4, do you get 7? Yes. What about when you multiply them? 3 times 4, you get 12. Correct. So those are the factors or integers we are going to use, and we are going to replace them with b. This middle part here is where we are going to replace 3 and 4. So I go to the next slide and write that expression again. So my expression is x squared plus 7x plus 12. So we have found that our values that we are going to use are 4 and 3, or 3 and 4. So we substitute them in the middle here. You get x squared plus 4x plus 3x plus 12. At that point, You factorize the first two and the next two. Check what is common in the first two. It is x. Once you factorize x there, you get x plus 4. Then plus that sign, you follow that sign. 3x and 12, what's common? 3. You get x plus 4. Now when you check out the factors inside the brackets are the same, so you pick one, x plus 4, and you combine the values outside the brackets. So here we have x, the first one, and we also have 3 there, so you combine them, x plus 3. And now this one is the factorized expression for this one, for that quadratic expression. So this is the now complete factorization of x squared plus 7x plus 12. Now having done that, you can try to do this one. This is your assignment. Try to factorize x squared plus 5x plus 6. Once you are done factorizing, check with yourself whether you are getting these answers. Your answer should be x plus 3 and x plus 2. If you won't get x plus 3 and x plus 2, you can check the next video. I'll have tackled this expression here. Thank you.